Hi everybody, welcome to Chem 2. I was too excited to get through this week without making this video to welcome you to the class. I'm really excited about teaching this class this year, and I just wanted to make this video to introduce you to the class, talk a little bit about myself, and just kind of like get the ball rolling in a positive way. First of all, I just wanted to acknowledge this is going to be an interesting year. Coronavirus has changed up a lot of things, and we're all in the same boat together. You guys are learning, I'm learning. So that's one of the reasons I made this video, is to try out something new. And I'm going to be looking for your feedback this year to see, is this stuff working for you? Should I be doing something different? Should we be doing something different together? And so please, feedback is great. A little bit about me. This is my 7th year teaching here at OA and my 17th year teaching chemistry. So that's a lot. I have my master's in chemistry and also my master's in instructional technology, which should mean I'm the expert in all of this. But like I said, I'm learning too. And so just realize that learning never stops. It just keeps going. I have a sailboat. I have a black lab. His name's Beaker. Get it? Lab. Beaker. Yeah, I'm a nerd. Speaking of nerdly things, on the board behind me, there's lots of chemistry stuff that I just wanted to talk about to kind of introduce the class and what we're going to be talking about this year. So first of all, up at the top, this is the chemistry triangle. This is the way that chemists look at the world. So chemistry is the study of tangible objects, or matter, pretty much. So solids, liquids, gases, not energy, although we will be learning a little bit about energy this year. So when chemists look at the world, they look at the macroscopic. That's literally, macro means big and scopic means see. So what we can see. And then we try to explain the macroscopic parts of the world by what the particles, those are submicroscopic, what they're doing, and also use symbols to explain it, like H2O is a symbol for water. So symbols, particles, what we can see and observe about the world, that's chemistry in a nutshell. But you notice this is a triangle. It's really a pyramid, because at the top of this is the human element. In other words, why does any of this matter? Chemistry only matters in so much that it's useful to human beings. And so we're going to be learning how chemistry is useful, which is the top here. So chemistry is useful for medicine. If you're looking to get into a medical field, this is going to be a really useful course to you. You're going to feel a lot more prepared if you go to a nursing program or a dentistry program or a dental hygienist program or a x-ray technician program. You can make a lot of money doing those things, and they require a good understanding of science, and you're in a good place to prepare yourself for that. Also, engineering and manufacturing. Chemistry is really big in that, how we make things. There's a lot of high-tech manufacturing in the United States that chemistry is a really important part of. Foods. Like food is chemistry. So we're going to be learning about chemistry of foods a little bit up this year, and what kind of cool reactions are going on in that. Law. I wanted to be a lawyer at one point. Decided teaching is something I like a lot better. But law is really useful. Chemistry is really useful for law, for patent law, for environmental law. Oh yeah, clean air, clean water. Those are important things, and chemistry is a key part of keeping the environment that we live in good for human beings and good for the rest of the world. Down here on the side are some topics we're going to study this year. Atoms, reactions, moles. You guys know moles. Stoichiometry, which is the measurement of moles in reactions. Gases, acids and bases. You might know a little bit about that. Equilibrium is something completely new. It's the idea that reactions can go backwards, and that causes all sorts of interesting things to happen. Kinetics is the speed of reactions. Thermochem is how energy is involved in reactions. Nuclear chemistry. If you want to save the world from climate change, become a nuclear scientist. Seriously, it's one of the best ways that we can change the planet, and nobody's really doing it anymore, and that's a sad thing. And finally, organic. We're going to do a little introduction to organic chemistry, so that if you ever take an organic class in the future, you'll be better prepared for that. We'll talk about how that interacts with foods and medicine and humanity and plastics and all sorts of things. So thank you for watching this video. I'm really looking forward to this year, and don't hesitate to reach out to me if you have any questions.